Okay, right. So we're recording there. Yeah, guys, and just a reminder about the noise and the fact that the room is small and your voices are not right. You don't talk on mute. So either you turn on the subtitles and you talk on mute, or you monitor yourself. All right. So let me see. D'Angelo here, Donovan here, Juliana here, Jaden here, Jay here. I'm not seeing Janaya. Jaziri here, Josiah here. Jaquan's mom said he was sick. Julie missing in action. Cassie, I think Cassie's a clash on a Monday. Right, Khalifa is here, Logan is here. Matthias, I don't know if Matthias with Matt, with me. Michael also out for now. Noah, Nyla, Paige, Shamor, and then Zian. Zian was supposed to resume. Um, Anyhow, but that's what we have. We have about 13 people out of about 22. So we have a little more than half the class. So that's a quorum. Um, All right. So with that said, let's get into the work. Right. So I know some of you all may have encountered this topic in school already. So we're doing it here, and some of you all may have encountered it, but may not be too, what's the word, fond of it. So we'll try to see if we can fix that here. All right. So we are still in the umbrella topic of trigonometry. Right. So sine, so basic SOHCAHTOA, sine rule, cosine rule, all those apply. All right. We won't be using angles of elevation depression in this topic. Not yet. No. All right. Okay, so let's start off with a bit of a definition. All right, so we're talking about bearings. Sorry, one sec. Oh, that is what 6 outdated drivers. That's why I was giving trouble. Right. So bearings. Right. So the bearing of one point A from another point B another right is the direction of A relative to B given by what kind of note starting over already? Why pressure any dance? Right. The clockwise angle formed between right the north line right at the starting point in this case that'll be B and the line connecting both points. So we need some examples to kind of drive that home, clearly. All right. So when I say the north line, I am talking about north as in the cardinal direction, cardinal point being like north, south, east, west. All right. Sorry, 1 second. Somebody coming out of the room. I don't know. Okay, cool. Right. So let's say we have a point B. Right, and we have a north line. Right, so that there is your north line. And let's say there's a point A somewhere off in the distance. All right, and there'll be a line connecting A and B. And as it says here, the bearing of point A from point B is the clockwise angle starting from the north line and going until it hits the line connecting both points, in this case, the pink line. Right, so that is theta. Let's call it theta for now, right? So in this case here, theta is the bearing of A from B. Okay, so we're done. So no more mysterious cats causing confusion, right? All right, cool. Not yet anyway. All right. Okay, later. Bye. All right, cool. So tomorrow. All right. I know I saw her car this morning after she dropped them. She was going back home. Cool. Cool. All right, cool. Well. Yeah. All right. So the Wednesday class you keeping? The Wednesday evening? Huh? With Sarah Hanifa. Okay, I'm pretty sure. Okay. Okay, cool. Okay. Okay. Cool. Yeah. All right. So yeah. So what I'll do is Drew, Sarah, and okay. Yeah. 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 So she needs past papers. Nothing. All right. Yeah. Okay. Cool. All right. Yeah. That's a hard switch. I agree. Yeah. And possibly Michael too. All right. Cool. All right. Cool. Well, we'll see how it goes. All right. Later. Yeah. Bye. Right, sorry. Right, so that's that one. Let's take a look at a couple more examples. So let's say we had a point C down here. And let's say we actually, no, let's move C up a little bit. Yeah, let's put C there. And let's put D down here, right? So again, we need a north line. In every bearings question, you must have your north line. All right? All right, so that's the north line at the start point, which is C, and we have a line connecting C and D, and the clockwise angle between them is the bearing of D from C. So in this case, so that's an alpha, right? So alpha, right, is the bearing of C from D. All right. What about if we had in the other direction? What does that mean? So let's say we had a point F. I won't use E because seeing as we have like north, E could be east, so we don't want to. Yeah. Sorry, you're correct. Bearing of D from C. My bad. Thank you. Right, and let's put G across here. All right, so we have a north line at F. So that's F there. And we'll put a line connecting F and G, right? And then we'll have the clockwise angle. Oh, come on, man, Philip, leave yourself. Right, so we'll call that one beta. So in this case, beta is the bearing of G from F. All right, so we have a point G there, and let's go a little higher than that. G there. Let's see, we have a K somewhere across there. Not entirely. Yeah, that could work. That could work. Okay. So that's the north line there, and of course, we need a line connecting J and K, and then the clockwise angle, right? Which we'll put as gamma. All right, so gamma, a kind of weird looking Y, is the bearing of K from J. Which one? Oh, yeah. Donovan, how are you feeling with that note so far, boy? So far, so good? Any questions? All right, cool. All right. All right, so I would have a space for somebody if necessary. We were sending person today. Javier, Julie, and Ziad. So we're missing three people. So we have one space there. One J Kwan. Missing Javier, J Kwan, Cassie. Five people. Do I have five seats? One, two, three, four. I don't have five seats. That's a problem. Yeah. Okay, cool. All right. In class, people, are we okay with the note so far? Are we okay with the concept of what a bearing is? It's simply the direction of one point from another given by an angle. But remember an angle is formed between two lines which must meet at a point, right? And of course, an angle can go in either direction, right? But here we're being very specific about which direction the angle must go. It has to start at a particular, on a particular line and go to in another line, right? And one of the biggest problems we have is people understanding which point is the starting point and which point is the ending point. So in other words, which point is from the other point, all right? So the diagrams are usually a good first point of contact for most people because they have to kind of clarify that. Right? Of course, if you're still having any issues, which is perfectly normal, please feel free to let me know and I'll see how I can help you. All right, so need to go on to the other page. All right, after going to the next page, so let me send it in the chat one time then. All right. All right, so most times what they want us to do is find what I like to call the reverse bearing. So that's the heading for this page, finding the, in quotes, reverse bearing. All right, so this is set one. Right. So in this example, the bearing of B from A is 060 degrees. Now, what you might be noticing here is that I'm writing three numbers instead of just 60 degrees, right? So the way in which bearings are usually presented is in 3 digits. So even if you have a 2-digit bearing, you're going to put a 0 in front of it. All right, so 060 is 60-degree bearing. What is the bearing of A? Right, so here, they give you the bearing of B from A. And now they're asking you, what is the bearing of A from B? Okay, so I'm going to do it like in a series of 3 diagrams. Now, when you're doing the actual questions, you don't need to do 3 diagrams. You'll end up doing 1. But I want to show the progression from one diagram to the next, all right? All right, so the bearing of B from A is 060 degrees. So let's start there. All right, let's put a point A. Let's put a point B. Now, you don't have to get a protractor or a compass or anything like that. You're just making a little bit of an estimate here, right? Right, so that's your north line there. Sorry. Let's push it down 1 line. So we have a little breathing space. Good. Right, so we have a north line here. We have that. We have the 2 points, A and B. And we have that the bearing is, I'll just put 60 degrees for now, right? Okay. Now, how do we find what I like to call the reverse bearing? So we have B from A. How do we find A from B? So if we have to find A from B, B is now the starting point, which means that we have to draw a north line at B now. All right, so in the second diagram in the series, let's shift it across a little bit more. We could do a little bit more, right? So what we need to know is we have to now draw a north line at B. And we have to put in the angle, the clockwise angle. All right. Now, what do we do thereafter? Now, you have different ways you could approach this. I'll show you the way I like to approach it, right? If you know a different way from school that you're accustomed to and you like to use, by all means, please continue to use it once you're doing the correct thing, right? So this is what it is, right? So what we do is we have to kind of extend the line connecting the 2 points. So this line here, we're going to extend it. And are you seeing a kind of F angle being formed there? Like if you take an F and it fall back, like it faint, right? So, and we have two parallel lines. In any diagram, all north lines are parallel. They could be skewed all how, but they're all going to have the same orientation relative to each other. They're all going to be pointing north. So all north lines are parallel. And when we have parallel lines, multiple parallel lines in a diagram, and there's this transversal, we therefore have opportunity to do F and Z angles. Now, what does that mean? It means that this angle here and this angle here are equal, which means this piece here is 60 degrees. Sorry, one sec. All right, so 60 degrees. Now, let me zoom in for a second here, right? So what we've done there, when we inserted the broken line, is we've cut that bearing, the green angle, into two pieces. We've cut it into a 60-degree portion, and then the other portion on this side, if you notice, this whole thing is a straight line, not so? And the angle on a straight line is 180 degrees, which means that the section down here is 180 degrees. So the total bearing of A from B would be the sum of 60 and 180 degrees, which will give us 240 degrees. All right, so therefore, bearing of A from B, sorry, one sec. Right? Now, I'll give you a little idea that occurred to me, right? If you went from A to B and you wanted to go back from B to A, you would just turn around and walk back, right? When you turn around, don't people say you make a 180 and go back from where you come from? Right. Why do they say make a 180? Because it points you in the opposite direction from which you came. And that's basically what we did. We took the 60-degree angle and we added 180, right? So initially, did it make sense? Yeah, right? So initially, if you think about your cardinal points, right? Know what? So you lost? Okay, cool. North, south, east, and west, right? So initially, if you look at it, B is what direction technically from A? Is it to the east, to the west? It's kind of northeast, right? Right. And therefore, that would make A the opposite. So if B is northeast relative to A, it means A is southwest relative to B. So if you reverse a bearing, going from northeast to southwest, basically all you do is you add 180 to the original bearing. That's all. All right? So again, the progression went from this, right? We started off with the original diagram showing the bearing of B from A, which the question gave us as 60 degrees. We then drew a north line at B, and we put the bearing that we were asked to then find, the bearing of A from B, which is the clockwise angle between the north line at the new starting point of B, and of course the line joining the 2 points. And then what we did thereafter was we simply, hold on, right, we simply extended the line joining A and B like so to create our F angles. How does it create an F angle? Because these two north lines are parallel. Right? So when you extend the line joining both of them, we could see that there's an F angle occurring there. All those are kind of sideways F angle. Right? And in so doing, this angle here and this angle here are equal. And therefore the remaining piece here, right, because it's on a straight line, is 180. So the total of this angle is the sum of the 60-degree portion and the 180-degree portion, which is 240. Okay. In class, people, how are we feeling with that? That's a slow nod. You understand what we're trying to do? Okay, cool. You okay with that? All right, Jair and Julian, you okay with that? All right, cool. My curiosity fellas, we all right there? No? All right, you understand what we're trying to do? All right. So they gave us that the bearing of B from A is 60 degrees, right? So you put your A, you put your B, and if it's B from A, it means you're starting from A and going to B. So if you're starting from A, A is your start point, so that's where you put your north line, right? So you put your north line there. And then the clockwise angle between that line and the line joining 2 points, they gave us a 60. Now, what they want us to find is the bearing of A from B. So the bearing of A from B requires that B is now the starting point. So you draw a north line there now. And then the clockwise angle from that north line to the line connecting 2 points is the bearing of A from B. Right. So now, when we do that, in order to find that angle, what we do is we extend this line joining the 2 points. Right? When you extend it, you have a kind of sideways F. Right? Which means that this angle here and this angle here are equal. They're both equal to 60 degrees. And then the remaining portion of the angle along there, because it's on a straight line, is 180. So what we do is we add those two portions, the 60-degree portion and the 180-degree portion, and then get 240. Yeah? All right, cool. All right, my far side. We okay there? Paige, Nyla, you okay with that? All right. Donovan, talk to me. You good with that?
Yes, sir.
All right, cool. Right, so there we go. So from there, I'm going to give you guys a couple of try. Now again, you don't have to draw 3 diagrams every time. That's just my preferred thing to illustrate the progression of the logic / the work. All right, so 1. Your line joining 2 points? Right. So if you're looking for the angle, you have to ask yourself, well, how am I going to find it? So if you were to draw it to scale, you could take a protractor and measure it. If you don't have a protractor and you don't have time, then you have to use what you have. So we have lines. So what we could do, we could introduce more lines. Just like in circle geometry. Sometimes you have to put in lines that are not there. Yeah. All right. So the bearing of P from Q is 030 degrees. Find the bearing of Q from P. And I'll give you a second one. So you have 2 of them to do for me. Bearing of T from S is 075 degrees. Find the bearing of S from T. Right, so I already gave you the shortcut, so I mean you kind of know how to find the answer already. But I would encourage you to draw a diagram that would end up. You'd start off here. You would put the extra line on the same diagram and then extend that other line on the same diagram. Right, so you're only using one diagram, but you're modifying it. Oh, cool. Right. So let's see how that first one looking, shall we? Right, so the bearing of P from Q is 030 degrees. So that's 30 degrees, right? So let's put a P, bearing of P from Q. Okay, so if it's from Q, it means Q is your starting point. So you have to put Q somewhere there. And then 30, so draw a north line here. All right, north. So clockwise, which way is clockwise? Going this way, all right? Anti-clockwise goes the next way. So we are going this way. So we're going this way about 30 degrees. So 30 degrees, again, is not a very big angle. So you can put it somewhere around, let me put it here now, right? So that's P. And that's the line connecting Q and P, right? And the angle, or the bearing rather, is 030 or 30 degrees, right? So we'll put 30 degrees there. Okay. Now what's the next one? What do I want us to find? So what we've shown is the first sentence that the bearing of P from Q is 030. Bearing of P from Q is 030. We okay with that one? When you give me a slow note, I'll be concerned. It's cool if it not too then, but let me know. But you had to ask questions. Okay. It means you don't understand it yet. But but you're in process. Right. So if we want to find the bearing of Q from P, we need to put a north line at P because P now becomes our new starting point. North line. Right? And we have to draw in the angle, the clockwise angle. Right. And what was the last step here? We extended the line connecting Q and P. So we're going to go here. Right? And in so doing, what have we done? We've kind of created this kind of F angle thing where this angle here and this angle here are equal. So it means that this piece here is, and because this is a straight line, the angle on it is 180. So the bearing of Q from P is equal to, correct. Okay. Right. All right, so I'll give you a couple of minutes again and we'll do part 2. Because I'm watching Who Not Here now. So Javier, when you come back, Jaquan, Julie, Zian, that's 4, and then the other guy Christian, that's 5. Anyhow, we'll figure it out. Right, so let's take a look at number 2, shall we? Or do we need a minute again? A minute. All right, cool. Go ahead. Right. So there we go. All right, so the bearing of T from S is 0.75. So T from S means it's starting from S, right? And 75 degrees is less than 90. So we know it's a same kind of northeast thing, right? So that's S. Put your north line, right? And then T will be somewhere around here. All right, let's put T there. Sorry, hold on. I will connect S and T. And we will put that the angle, the bearing of T from S is 75 degrees. Right? All right. Are we okay with how I did that? Okay, cool. The bearing so we want the bearing of S from T. So now we need a north line at T. All right, so let's put a north line at T. And we also want to extend the line connecting S and T. And let's draw in the angle now, the clockwise angle. Right. Right. So because of the mutual parallel, right? Because those two north lines are mutually parallel, and we have this line connecting them and passing through them, we have F angles being created, which means that this angle here is also equal to 75 degrees. And this angle down here is on a straight line, which makes it 180 degrees. All right, so, yeah. $75 from 90. Yeah, adding them together. Yep. Because you go in 75 degrees and then you're going 180. That'll give us this angle here. And then if you want, you could subtract that from 360. Okay, that's fine. Yeah, so 105 from 360, I think is what, 255, yeah? Yeah, Juliana, you can work with that. Yeah. Therefore, bearing of S from T is 255 degrees, which is the 75 degrees plus the 180 degrees. Okay. Okay, you okay with that one? All right. My middle section here, are we okay with that item on the screen there? All right, far side, my exam people and D'Angelo, we cool with that? Screen, you good with that solution? Yeah? All right, page Nyla. All right, cool. All right, don't everyone talk to me, we good there?
Yes, sir.
All right, cool. Okay, ladies and gentlemen. I'm recording this, right? I did put it to record. Oh, thank God. Right, cool. Right, we're going again. Right, so set 2. Right, let's go. So we have an example here. Example 2. So it says that the bearing of D from C, right, the bearing of D from C is 120 degrees. Right, so what you will notice here is that this angle is greater than 90 degrees. So if you think about your quadrants, right? So north, east, south, west. And going here, that's 90. And then going here, that's 180. So 120 is somewhere down there. And that is the southeast quadrant, right? So if the angle is between 90 and 180, you're in your southeast quadrant, right? So now we want the reverse bearing. What is the bearing of C from D? Yep. Sorry? Well, let me see. All right. So you have your little theories, right, which is good. Right. So we have a bearing of D from C. So if it's from C, C is your starting point. We're going to draw a north line at C. Now again, 120 is somewhere down. If you imagine that 120 is somewhere in that quadrant down there. So again, you don't have to get a protractor, you don't have to measure any angle, anything like that. Just going to put a random point D there, right? And we're going to connect those two. Am I going to have enough space if I do that? Yeah. Okay. Right. And the angle here is 120 degrees. That's the bearing. 120 degrees. Right? And this is D from C. Right. So just like we did in the previous question, we are going to draw now a north line at D. Right? Because what we want is the bearing of C from D. So we need the clockwise angle. All right. So what do? Well, we do the same thing we did before. We extend the line joining the 2 points. And what do we see happening? The same thing that happened before. We see the formation of the F angles, which means that this angle here, this piece here is 120, and the other piece down here is 180 degrees. So the total bearing, therefore, of C from D will be the sum of 120 and 180, which is 300. Bearing of C from D is 120 plus 180, which is equal to 300 degrees. Right, so I'll give you a minute or two to copy that down. In the meantime, I'm just going to draw a little separator line here. Put the next two questions one time. Right. So I'm just going to continue the number from the previous. So question 3. Right. So the bearing of T from S is 165 degrees. Right. Right, bearing of Q from P. (95°). All right, find the bearing of P from Q. All right, so two similar questions, right? And these are initially, I guess you could call them obtuse angles, bigger than 90, less than 180. All right. Okay, cool.
I have nobody in my contact, so I want some suggestion. So unless that's like a middle name or she gave me a middle name or something.
She sure it's me? She came to lessons or she was like in a live or something online? Yeah, might have been. Right, so let me start with our first one there. Ooh. Okay. Bearing of T from S is 165. T from S. Okay. So S is here. Let's get a north line going at S. 165 is somewhere down here. Let's call that T. All right, so that whole angle there is 165. Right, so we want the reverse bring. We want S from T. All right, so we had to put in a north line at T now. And we had to extend the line connecting S and T. Right, so the angle we want is the clockwise angle, right? So now what we're seeing here is that this piece, this angle here, that's the 165. That's the F angle corresponding to the 165 here. And this one down here is 180. So the total bearing there is what? 345? 345. Yep. All right. So bearing of S from T is 345 degrees, which is one. All right. Okay, I'll give you a minute or so to finish on the next piece. Sorry, I forgot. Right, there we go. Okay. Bearing of Q from P is 95. So, okay, so 95 degrees is almost a right angle, right? But it's P from Q. Sorry, Q from P. So 95 degrees would be like maybe somewhere around here, right? So let's put that there. So that is 95 degrees. All right, cool. So what we want the bearing of P from Q. Okay, cool. So let's put a north line of by Q. We'll show the angle we want, which is that angle there. And now we extend the line joining them, which cuts it into two pieces. This piece on top here being the F angle, 95, and this one down here being the 180. All right, so bearing of P from Q is the sum of those two, right? So 275 degrees. All right, cool. Okay, so in class, people, are we okay with those items there? Any questions? Anybody? Anything? No? All right. Donovan, talk to me. You okay with that one?
Yes, sir.
All right, cool. All right, so seeing some people copying some stuff, so I'll give you a minute or so. All right, cool. Let's go on to page 4. All right. So this is set 3. So now we're talking about southwest to northeast. Right? So in the previous 2 pages, we initially went east and had to go back west. Now we're actually heading west first and having to go back east. All right, so example 3. Right, the bearing of H from G is 200 degrees. 4 months will fly.
It's 99 days, Chris.
How is it 99 days?
To like oral.
Oh, orals. Nothing. All right. Right. What is the bearing of G from H? All right. So you know what we do. So 200 means it's going to be on the other side, right? So let's start off. So the bearing of H from G. So initially we're going to start at G. We're going to get a north line at G and 200 degrees. So again, if you think about it from the quadrant perspective and we're going clockwise, that's 90, that's 180, that's 270. So somewhere inside of here, we have a 200 degree angle, right? I guess we could put H down here. Let's put H there, right? I will connect it and we'll put 200 degrees, right? Okay, so we're going to do the usual thing. Let's copy and paste the diagram. Right. So now we need a north line at H. Let's put a north line at H because now we want G from H, right? So north. And don't forget, it's the clockwise angle we want. So look at the angle here. From here right to there. So we want that angle. And what's the last thing we do? We extend the line connecting H and G through G. No, that's not what I asked for. Behave yourself. Thank you. No. What are you doing there? Behave yourself. Right. Copy. Paste. Right. Now we're talking. Be out. Right. So, diagram 3. The third one. Yes. Right, so we're going to extend that line back through G, like this way. Now what that does, let's zoom in there for a second, right? So what that does is it breaks up that 200 degree angle. So it breaks up the 200 degree angle into 2 pieces. It breaks it up into a 180 down here. And the remainder here will be what? Which means, therefore, that this angle here is also equal to 20 degrees. So in this case, instead of adding 180, we had to subtract 180, but it's still 180 that has to be used. Because again, it's like you're turning backwards to go, right? Technically speaking, yeah. Yeah, one second. I just want to put in the so the bearing of G from H is 200 degrees minus 20 degrees. Right. So I'm just going to put a little separator line, and I'll start writing out your questions for you to try. So remember, in this case now, we're heading, we went west first, and now we're heading back east. Right. So bearing of E from D find the bearing of D from E. And number 6. Find the bearing of Y from Z. Right.
I would never flexible enough.
Okay, cool.
Did you see Miss Price in the green dress? Yeah, no picture looking. Culturally appropriate. I don't think everybody went quiet when I said.
Okay, no problem, another one. Do things.
You back? All right, cool.
Right, let's get some diagrams going there. How y'all feeling with bearing so far, boy? All right, glad to hear that. Anybody not so good? That's okay too. All right. Bearing of E from D is 240. E from D. Okay, so E is the starting point clearly. 240 is almost 270. All right, so that's E. I shouldn't have used E, but anyhow, we'll do that. That's fine. So we'll start with a north line at E, right? And then 240. So again, if you do this, that's 90, that's 180, that's 270. So 240 is somewhere in that lower southeast quadrant there. Right. That's D, right? No, the bearing of E from D. Sorry. So this is supposed to be D here, and this is E here. And that is 240 degrees. Right, and they want the bearing of D from E. So what do? We put a north line at E. We show the angle that they want us to find, and then we, of course, extend this line back, cutting that angle into a 180 section down here, and then this, of course, will have to be 60 degrees here, which means that this angle here is also 60 degrees. So bearing of D from E is 60 degrees. Okay, how are you feeling with that first one there, guys? Yes, no, maybe? Yeah, okay. Which almost like she has antennae, you know, that's drooping.
I said I look like the thing from Buzz Light. Like the cockroach thing.
Point. Right, the bearing of Z from Y is 190. Z from Y. So Y is the starting point. So that's Y here. Let's put a north line there. And then 190 is just a little bit past 180, right? So about it? Okay, so we put Z there. Yep. And then the angle there is 190 degrees. But they want the bearing of Y from Z. So what we're going to do, we put a north line at Z. We'll show that this is the angle that they want here. And we're going to extend this line back. Right? Which therefore will cut that 190 into a 180 section and a 10 section. Which means that the blue angle is also going to be 10 degrees. Therefore, bearing of Y from Z is 10 degrees. Okay. How are we feeling there, guys? The Zurich Khalifa, are we okay with that one there? Yeah? All right, cool. All right, Logan, Juliana, Jair. All right, talk to me. All right, Jaden. No, are we good there? All right. Far corner, are we okay with the bearings there? Page, Nyla. All right. You took it out? Yo. Up here? All right, Donovan, talk to me. We good? We good with the 5 and 6?
Yes, sir.
All right, cool. All right, anybody copying anything down, or we could go ahead to the next one? Next one? All right, cool. There we go. I feel like I need a little assistance with the ice balls. Okay. All right. Set 4. All right. This one is northwest to southeast. Okay, let's go. So example 4. The bearing of U from T is 320 degrees. What is the bearing of T from U? I know I heard the wrong thing, right? So we'll just leave that alone for now. Right? You were talking about teeth? Okay, good. All right. Right, so the phrase was bottom row. Okay, cool. Right, just making sure. I did not hear that. Not that. Not that. That's what I was wondering. I'm like, what kind? This is not a biology class. Leave yourself. Time for a checkup? Yeah, I agree. I need one. I might have to introduce my sons to that, because the only doctor there is Dr. McWheely. I think it's a Russian little the little girl. She's a cartoon girl. She fixes cars, but she talks. Dr. McWheely, and they can't decide if it's MC for Muck or MAC for Mac, and it changes. Anyhow, right. So we have a 320 degree angle going on here now, guys. So let's take it. So the bearing of U from T. So we had to start at T and put a north line. North. So again, if you take it in, so that's 90 to 180 to 2, that's 36. So 320 is somewhere up inside of here. Right, so let's put that as U. And the angle is 320 degrees, right? it down one. Right. Copy and paste time. So what do? We want the bearing of t from u. So we need a starting point at u, which therefore requires a north line. It's the north. And we're going to put in the angle there. Really? Right, so now we're going to do what? We're going to extend the line, joining those two, and it's going to break up into a 180-degree portion. And this piece here will be 320 minus 180. Which is 140. Right, so bearing. Which chair is squeaking? I'll swap it out. Which chair it is? A chair real squeaking. So I'll swap it out. Which one it is? Alright, swap it out one time for me.
This one's been squeaking since fall.
It's actually my chair.
Right next to Michigan.
Oh, yeah, that's
Chris, I'll just move our chair to inside.
swap it with that one.
Oh, she knows
Oh, swap it with that one. That's good. All right, cool. So while you're copying that down, I'll put in the whatchamacallit, the two questions for you to do. Yeah. That's a good question. I'll check my schedule. We're doing stats. So stats is a kind of plug and play thing. So even if it's not me, it's Mishka, but I supposed to be, it's supposed to be me. $500 million I losing. Wow. Oh wait, I forgot the right question. 8. My bad. Wow. I zoned out there and forgot what I was doing. $345 is almost 360. It's almost a full circle we're going with there. L from K. So we gotta go at K first. Draw a north line. 345 is. Let me just say wrong here now. Okay, wow, that's not a very straight line. Yeah. Let me say L. And then that angle there is 345. Yep. Now what do we want? We want the bearing of K from L. So we need a north line at L. Right. So we want that angle there. So what we have to do? We have to extend the line. So that green line has cut the 345-degree angle into a 180-degree angle, and this is 165, the difference, right? Which means the pink angle, the angle we're looking for, is also 165. All right, so bearing of K from L. $165. All right, I'll give you a couple of minutes again to do number 8 because I kind of put that one in late. I have a last page after this with the cardinal points. What I might do, I might just put it up on the board and talk you through it, and I'll just copy and paste it and add it to the PDF that I'll send after class, right? No, it doesn't make sense. What is that? What's right in exam? God. What did you put there? Seasoning? Oh yeah, okay. That's how it's supposed to look. Bacon. Eggs, beef, bacon, cheese, ketchup, or something. Right, is the food we're looking for? Alright. Interesting. Oh. Okay. Okay. Alright guys, let me do this last one and then we're gonna talk to that last piece real quick, right? Bearing of C from B is 295. So 295 is just after 270. So we're talking about not a little more than west. We got, all right, cool.
Tomorrow or
Yes. So to message me tomorrow because I had a message you kids and some of them mightn't start back anyway. So I had to let you know.
once again.
All right, cool.
On this one, on us.
Yeah.
Everybody.
So right, so B. All right. Let's get my north line go in there. And we'll do 295 around there, right? So that's going to be C. So that angle is 295. Right, so we want B from C. So we need a north line at B, at C, sorry, my bad. There's the angle we want here. And what do we do thereafter? We extend the line connecting B and C, which cuts the 295 into a 180 and clearly a 115. So this is therefore 115 degrees. All right, so bearing of B from C is 115 degrees. All right, okay. Before we lock off for the day, again, I want to actually copy and paste a page from across here. All right, so the cardinal points, right? So if something is straight north, it's directly above something else, and the bearing there will be 0 degrees, right? If B is directly due north of A, right, it means that there's a 0 degree angle, right? You could say 360 degrees, but it would be the same as 0 degrees, right? And A is due south of B. So what's the angle there? If A is due south of B, the angle is 180. If an item is due east, right, the bearing there is 90 degrees. And the opposite is what? The opposite is west. And the bearing there is 270. All right. Okay. All right. So guys, that's about it for today. When we come on Wednesday, you're getting some past paper questions with bearings in your tail. So these tend to be some of the more challenging ones, although in recent times it hasn't been that bad. The 2021 Jan question, I think, was a doozy. Since then, it hasn't been that bad. But we have to practice at least a few days. CSEC? That's a good question, boy. 2019 was actually pretty challenging. 2024 was not that bad. It wasn't. That's because what happened was they put question 2 that chain up everybody early. So what happened was it psychologically affected them negatively. So the rest of the paper therefore seemed harder by comparison. It wasn't that bad. Anyhow, don't have to go on there. I'll see you on Wednesday, right? Later.
Yes, sir.
Yeah, man.